Hello friends. So today I am going to explain you in this video about how to make the MATLAB diagram for to perform the practicals on the simulations as well as unsymmetrical point. There is also my another video. In that video I have added how to run the simulation diagram. But in this video, especially is for how to find the block diagram from the for the simulation and how to connect it, what parameters are required. So that part will be discussed in this video. So we will start this. So there are basically two types of faults are there, symmetrical and unsymmetrical. So first of all, we will go to the library browser. In that library browser, first of all, we will require source because we are creating the fault. So first we will require the source. So from you have to click on the Simulink, and after Simulink, you have to click on the Simscape. From Simscape, then click on click on Specialized Power System. You have to find the block that is Specialized Power System. You will this we will get from the Simscape. In Simscape, electrical specialized power system. You have to click on most of the blocks you will find out from specialized power system. Now in specialized power system, very first block that is nothing but power guide, which is nothing but the library of the MATLAB simulation. So we will select this and we will drag on the MATLAB simulation sheet. Then we have to double click on this block. After that, we have to make this as a discrete and keep this value as 1 e raised to minus 4. Keep this value as 1 e raised to minus 4. Then click on apply and click on OK. So now after that, we will require three-phase source. So from specialized power system, now you have to click on the sources. From sources, if you go at the bottom, then you will find out the source that is three-phase source. So you have to drag it, then it will be added on your sheet. Now, after that, now see, I will show you the diagram. So this is the actual diagram that we have to make. Okay. Now, after the three-phase source, what is there? This is nothing but your three-phase breaker. So how to obtain the three-phase breaker in the system? So for three-phase breaker, you have to go to the power grid elements. In power grid elements, you will find out the breaker. The first block is only breaker. We want three-phase breaker. So we will find out the block that is nothing but your three-phase breaker. So this is the block three-phase breaker. You drag it in your sheet and you will keep this on your in front of source. Now after this, now we need to measure how much voltage is there, how much current is there. So for that purpose, we will require measurement block. So how to obtain measurement block? So from specialized power system, we will go to the sensors and measurement. From sensors and measurement, you will find out the block that is nothing but your measurement. So the name of the block is three-phase VI measurement. That is three-phase VI measurement block, so which is available at the bottom. You will keep this in front of source, in front of breaker. Now after that, after the three-phase breaker, now you will require load. See how to obtain the load. Load means it is a passive element, right? So we go to the your passives. In the passive, you will find out the load. You have to carefully check the load. We are taking now here series three-phase series RLC load. The three-phase name you have to check specially first. There is three-phase series RLC branch is also there and three-phase series RLC load is there. So you will select the three-phase series RLC load and you will rotate this by using the keywords keyboard board, that is control R. So you have to rotate like this. So such as it will be in front of your small ABC parameter of measurement. So like this, you have to keep the position of the load. Now after that, as our experiment is basically symmetrical and unsymmetrical, so we need to create the fault. So how we can create the fault? So the we from specialized power system go to the power grid elements. In the power grid elements, you will find out the block that is a three-phase fault. So three-phase fault block is there. So you will keep like this. Now we will keep the position of that below the load. Okay. Now again we will require one function that is known as a step function. The step function that is required to switch the fault. Okay. So the step function you will get it from sources. So from now step is not electrical element. So we have to go to the first block that is Simulink. From the Simulink, then we need to go to the sources. From the sources, you will find out the block that is a step function. So the step function we will keep now here below the fault. Okay. Now after this, see, we have created the step function. Now after that, we will require, we have to measure input signal of voltage as well as current from the measurement block, and which is to be given to the, these are the demux. Demux means here one input and multiple output, and we also require the function of scope function. Okay, so how to obtain this, that I will tell you. Then you have to find out the demux. So demux means sync. You have to go from Simulink to the sync. So in the sync, you will find out the block that is your our scope function. So we will keep your scope function. Now it is three-phase. So so see what I am doing here. So double click on the block, then you then go to the setting. From the setting, click on number of input ports are 3. Click on apply, click on OK. Then you will find that there are 3 blocks are there. You can increase the size of that block slightly. Then control C that block and control V. We will require the 2 blocks. One block is for voltage and one block is for current. Now we will require demux. Now where we will get the demux? The demux will be available in the from Simulink to the signal routing. So we will go to the signal routing. In signal routing, you will find out the block that is demux. So keep demux in front of scope. Then there are only 2 outputs are there. So we have to make this as 3 output. So for that you have to double click on that block, click on apply, click on OK, and then you have to increase the size also of that demux so that it will match it. Okay. Then control C and control V. Then again we have to make the second block that is control V. So these are 2 blocks are there. So now here we have substituted all parameter except only relay. Now first of all, now we will make the diagram. So double click on the 3-phase source. Now keep frequency as 50 Hertz. Okay. And keep phase to phase voltage. Our voltage is, we will take 440 volt, and we will mark this as apply and click on OK. Then again we will click on the breaker. We will keep the initial status of the breaker is close, and we will mark this as a external and click on apply and click on OK. Now after this, we will click on voltage measurement. Voltage measurement, it will change as per the fault. If we are measuring voltage from single line to ground fault, then it is phase to ground. When any fault is with respect to line, or there is no ground is present, then we have to make this as phase to phase. Okay. Then we will double click on three-phase fault. We will make this as external. Click on apply. Click on OK. Now we will connect the wiring here. So we will connect the wires like this. You have to connect the wires like this. You can change the position of the block so that the numbers of wire will be parallel to each other. Then similarly, you will click on this is voltage measurement A, B, and C. Then small ABC is given to this block. Automatically, it will show the points where to connect. Okay. Now the point number A is connected to line A in the fault. Similarly, phase B is connected to phase B. Similarly, phase C is connected to phase C. And after that, this is a step function. The step function, you have to make this as a step time as a 0.1. Step time, you have to take as a 0.1, not as a 1. It is as a 0.1. Don't do other changes. Okay. Only it is 0.1. Click on apply. Click on OK. Then click that step function to the fault block common signal. You can arrange the position and wire also so that there are no overlapping. Okay. Okay. So this is your step function. Now we will connect the voltage signal to similarly we need to connect the current signal to this. You have to arrange the position correctly so that there will not be overlapping. So this is your wiring diagram. Now see, at the breaker condition is closed, but there is a common signal. So common signal is open. So you know that before the breaker, we will require relay because whenever the fault take place, you need to sense the fault, right? So for that purpose, we will require relay. So now we will make the diagram of relay. First of all, we will save this. Otherwise, whatever we have done, that will be unchanged and we will lose. Okay. So we will save this, the file, this MATLAB file. Click on save. We are saving now it on desktop. Okay. So now my file is saved by dp new. Okay. Now after that, I will create another file. So go to the new, click on the blank model. Now in this blank model, now we are going to create the relay diagram. So how to create the relay diagram? So for that purpose, I will tell you, first of all, you not need to go to the electrical point, right? Okay, this is a Simulink. From Simulink, first of all, you have to find the input function. So input function, you will get it from source. So click on the source, then you will find out the input function. So the input function I have kept like this. You have to keep, we will require, our system is three phase, so we will require three input. Okay, so we are now consider this as a three input. After that three input, I will show you what diagram actually required. See, this is the actually relay. If you click on that, then this is your our subsystem. So after that, we will require this relational operator. We will require a relational operator. Then how to create the relational operator? A relational operator, you will get it from the block that is logic and bit operation. So go to the logic and bit operation and you will find out the block relational operator. This is your relational operator. So we have keep this as a relation operator. You have to keep the position of the relational operator as greater than. Okay. So we have to change the sign. So you have to click on the relay block diagram and you have to select the relational operator as greater than. Click on apply. Click on OK. Then make as control C and paste 2 times for the 2 inputs. Okay. So we have used the 3 relational operator. After these 3 relational operator, now we have the flip flop. So now where to get the flip flop? So obviously we have to go to the now flip flop. You will get it from it is not available in the list. So Simulink extras. There is a one block that is known as a Simulink extras, which is not in courses here. Simulink extras, it is a separate block. So you have to come out from Simulink library. You have to go to the Simulink extras. In the Simulink extras, you have to find out the flip-flop, additional lookup table. There is a block that is a flip-flop. In flip-flop, we need SR flip-flop. So we will drag it on the your sheet. So this is your SR flip-flop. We will make Control C and we will paste it 2 times and we will arrange the position of this in front of your individual relational operator. Okay. After this, now we will require now AND function. AND is a logic gate, right? So you have to go to the again logic gate. So you have to go to the logic and bit operation. So again you have to go to the Simulink. In Simulink, you have to find the library logic and bit operation. In logic and bit operation, you have to find out the block, logic block as a and as a logical operator. We will require only one. Okay, so we will make this as a common, bigger. Now you have to double click on that. We will require number of inputs 3 and outputs will be 1. Okay, so that for that purpose we will require AND function. Now our data is totally electrical, but this will be in the form of logical operation. Okay, so we need to switch this. So for that purpose, we require data type conversion. So which will convert the logical operation into your actual value. So that is a double value. So where you will get double value? So that is a logical bit operation. That is a data type conversion block actually. So data type conversion block you will get from signal attributes. Go to the signal attributes. From signal attributes, then there is a block that is a data type conversion. Double click on that of data type conversion. Then keep this as a double data type conversion. Output, we have to make this as a double. Don't do other changes. Click on apply. You have to make only double only. Okay. So this is only double. Now we will do make the connection. Similarly, we will connect logical operation get to this. You can change, you can arrange the position of the wire also so that it will be straight or it will remain same. Okay. So like this, we can keep this position. Now you can see that there is a one terminal is open for the SRP block. So we have to connect this by using constant. So constant function you will get from Simulink to sources. So go to the sources. From sources, then you will find out the block constant. You will require to block one. We will keep this as a control C and this is control V on these sides. Okay. So we will connect this block like this. Okay. Similarly, we will connect block like this. Okay. Now we have to now almost now this is the one terminal is there that is at the SRP block. So we have to terminate that. So we will require the function terminator. So go to the from Simulink to the sinks. From the sinks you will find out the function that's a terminator. So control C that point and you will require again two functions. So we control V again control V. Okay. So these are the terminators. So terminator we have connected. Similarly, we need to connect the AND function to the double, which convert logical bit operation into the double. Now we will require one output here, right? That is nothing but your double into output one. So output one here you will get it from the sink also. So in the sink you can see that there is output function. So we will connect the output function here and we will connect like this. Okay. So this is the we have made here relay diagram. Now we have to do certain changes in the logical in the relay diagram. So that I will tell you what changes you need to keep in the diagram. So first of all, you can see that there is a relational operator. So double click on the relational operator. You have to keep as a relational operator. So here there is a constant term. The constant term you have to enter here as a 33. You have to enter the value as a 33 as a constant value and you have to consider signal attributes as a double here. You have to consider signal attributes double. So this is a signal attribute doubles we have considered. And we will make this apply and okay. Similarly, there is a one constant for SR flip-flop. Now flip-flop is mostly operated on logical bit operation. So here, the for SR flip-flop constant value is 0. Constant value is 0 and signal attributes, it will be Boolean. Signal attributes will be Boolean. So click on apply, click on OK. So this arrangement we have then relational operator now it is greater. So you have to check that this is a data type is Boolean. You have to just verify it. Don't do any other changes. Okay. So this is we have made the relay diagram. Now you have to select that diagram like this total diagram and after selecting it you have to right click on that and you have to create the subsystem. You can see select the relay diagram, right click, then create subsystem from selection. So you will get the subsystem diagram. So you have to make this copy and you have to paste this diagram into your MATLAB diagram. So you will keep the MATLAB diagram here, and we will connect the relay function, and we will connect the relay function to the common. That is output part. We will connect to the relay function. Now there are inputs are left for the relay. So the input for the relay, that means it will measure the parameters from the your voltage and current. So voltage and current. So we will connect the diagram. So one we will connect to this part. Similarly, second we will connect to D part, and third we will connect to C part. Now just we will rearrange this diagram so that there will not be any confusion. Now I think it is okay. Just come outside. Okay. So now we have connected the diagram, and whenever you will run the simulation, then you have to keep this pointer as a you can try for point 1 also and point 2 also. Now I am keeping this as a point 2. Okay. After this, now we have you have to also check that condition of three-phase breaker is closed. Then floating scope we have also keep into the 3. This is the diagram. So we have completed this diagram. Now you have to keep the stop time as a point 2. Then you have to save this program, and then you have to check whether is there any error or not. Now it is compiling. If you take simulation time more, stop time more, it will take more time. Now it is showing no error. So now we can run this program. So there is option that is run. So we can run this, and then we can check the waveform by double clicking on the voltage. So now, right now, waveforms are not visible because we have not created the fault. So go to the into the three-phase breaker. Suppose if I am taking single line to ground fault, then consider any one phase as a mark and ground. Click on apply and click on OK. Then we have to check voltage measurement. Voltage measurement should be phase to ground as we are measuring the single phase to ground fault. Then you have to save it, and then okay, so we can check the output. So by clicking run, so this is a current scope. If you click on current scope, then you will observe that now this see the one we have created. This is a line to line fault, and this is the current waveform. Now the voltage magnitude that you are observing for the phase B and phase C up to the point 1, now they are constant. Okay, but after point 1, your fault is occurring. So your fault current is very high. So you can see the scale is for 50. And if you see the phase A, the scale is from 0 to 4. The scale is from 0 to 4. It means that your normal current is up to 4 nearby 4 ampere. But when the fault take place, then the magnitude of the fault current is beyond 50 ampere. So that is we can do the analysis from the simulation fault. Similarly, you can check the voltage. Now it is line to line fault. Now see if these are the waveforms are there. If you want to see on the single phase, then click on these three icons, that is layout, and make this as a 3 output. Then you can check this output as a 3. If you want to check, take the printout. Now see, these are the line to ground fault, and we have taken here voltage measurement. Actually, here voltage measurement is phase to phase. Okay, so that's why we are getting the voltage like this. If you want to change the background for the purpose of printout, then you need to change the color. So you can click on the color. Figure color will be same, but just you have to change only axis color, that is as a white, and active display as one, and click on apply, click on OK. Change it as a black, or it's a change. Yes. So we can change like this. You have to go to the, you have to go to the from setting to style. Then you have to change axis color to white, and this color tick labels and grid color will be grayed. Now you have to select the active display 2. It is showing in black. You can consider this as a black. You click on apply. Similarly, you can click on active display 3. You can make this as a black. So this is apply. Okay. So you can take the printout of that. So this layout is very useful while taking the printout. Now I will just tell you how to change the fault. So if you go to the fault block, then there is a no fault is created from phase to B. Now I will show the fault measurement for single line to ground fault. That is for this is line to ground fault. Click on apply, click on OK. Then run. And you have to also now when as we have done the single line to ground fault, so voltage measurement will be phase to ground. So voltage measurement will be apply. Voltage measurement will be phase to ground. Click on apply OK, run, and then we will check the waveform, current waveform. Now these are the waveform for single line to ground fault. Now you can see that the fault is created between phase A. So the fault magnitude after the step time for 0.1, it is 100 ampere. But for the phase B and phase C, you can check the current magnitude is up to 4 ampere. It is a current magnitude. Similarly, you can check the voltage. So you can see that after the step time of 0.1, we have created the fault, and because of the fault, the phase A voltage it falls to 0. You can check the rated voltage, that is up to 400 volt. Axis color is not changed. Okay. Now you can see the rating. So voltage is up to 400 rated voltage. But when the fault takes place, then it is 0. Similarly, you can create the fault now for double line. I have shown now double line to ground fault that I will show you. So you can make fault any two phases. We will see now fault between phase B and C, and that is connected to ground. Click on apply, click on OK. If it is with respect to ground, that means voltage measurement will be phase to ground. Voltage measurement phase to ground. Okay. Then we will run, save and run this. And you can check the current waveform. You can see that the fault is created between phase B and C. So the fault current magnitude is up to 80 ampere as per the scale. 80 ampere, that is after 0.1. And in normal phase A, the normal current is up to 4 ampere. Okay, similarly, you can check the voltage waveform also. Voltage on phase A is healthy and fault take place on phase line to line fault. So fault on phase B and phase C. So your voltage is falls to 0 after the step time for 0.1. Is it clear? So I have shown you line to line fault, similarly single line to ground fault and double line to ground fault. So here in this video, I have shown you the actual setup of the simulation diagram. Okay, as well as for the relay also. So relay is a subsystem. Relay means subsystem. If you double click on that, you will get the relay system. We have to create that. So thank you for watching this video.